What does LD do? We test audiometers. We verify the compliance with manufacturer specifications. We verify compliance with the industry standards. We do not test a device called a tympanometer. That's a special device using to measure disorders of the middle ear. The calibration process then, LD does the test. If a fault is found, the audiometer is adjusted, perhaps even sent back to the audiometer manufacturer. Then again it's tested, and you can produce a report using the Larson-Davis equipment. Terminology, what does it all mean? The sound pressure level, abbreviated as SPL, it's an actual sound pressure in units of Pascal, and this is typically reported as dB. It's relative to a 20 micropascal, which happens to be the threshold of hearing. The RATSPL, the reference equivalent threshold sound pressure level, equates the sound to this human threshold of hearing, an average human, by the way, if there is such a thing, and then specific to an earphone type. The audiologists are typically talking in hearing level, or HL. So an audiometer, as you spin the dials and work with the audiometer, it's going to call out a level in dBHL. If we're working with the little bone vibrator and putting a signal into the bone, they talk in units of force level, or FL. So that's how an audiologist works. What to measure? Hearing level is a typical test that is done for an audiometer to see how it's performing. If we use our 1000 hertz example, the measured SPL we see coming in at 77.9 decibels, which is close to that 77.5 ideal. If we look over here at the hearing level, we see that at 40.5. We see that at 70.4 for the 1000 hertz, and a deviation of only 0.4, well within a target range for the standard. It can be within 74 to 80 and still be an acceptable level for an audiometer. We can also measure the bone vibrator level, as we talked, that little artificial vibrator. Again, if we use the example at 1000 hertz, we see a measured FL, or force level, of 81.6. That equates to an actual hearing level in vibration terms of 40 dB would be the ideal. This one measured 39.1, giving us a deviation of 0.9, and again well within a target level that we'd like to see, the force level somewhere between 79 and 85. We are also interested in the frequency response of the audiometer. If we can take again an example here of 1000 hertz, we'll notice that we measured the audiometer at 1005 hertz. And 5 hertz seems like a fairly large deviation in today's standards. As we look at the target, we're allowed anywhere from 990 hertz up to 1010 hertz. And the audiometer is considered working properly, even with these larger deviations. Linearity is another test we like to do on the audiometer. This one shows a measured step of 10 decibels. Ideally, if we change that attenuation by 10 dB and come down 10 dB, it should track. It should track 10 dB for each step, and we can see a variance of a few tenths of a dB as we go down in level. Again, very well within the target step of somewhere between 9 to 11 dB is acceptable for an audiometer. Harmonic distortion is sometimes referred to as total harmonic distortion, or THD. The maximum THD allowed for different frequencies by the standard is 2.5%. Most electronics today can easily accomplish that. And so again, using our example near 1,000, we see the level, we see harmonics, and all of those totaled up, giving us a total harmonic distortion of only 0.4%, well within the 2.5% that's allowed.